Okay, so raise your hand if you chose table A as not belonging. Okay, I don't see anyone. Raise your hand if you chose table B as not belonging. Okay, raise your hand if table C is not belonging. And raise your hand if you chose table D as not belonging. So let's see how good my memory is. No one chose table A, but one reason that I heard in a previous class is that table A is the only one where the first X value is not 0. It could really be as simple as that. Like sometimes they don't have to be like, of course, we'd love for you to attach the math vocab stuff, but sometimes it's as simple as that. And what we could attach as math vocab in regard to that one, what feature of the graph is it when the X is 0? The y-intercept. So if you were choosing table A as not belonging, or you had to give a reason for it not belonging, you could say table A is the only one that does not include the y-intercept. If you really want to be mathy about it, instead of just saying like doesn't have a 0 for the X, you could say it does not include the y-intercept. All right, what else about that could I say? Yesterday we learned that if it was day, time, hours, we know that when it's 0, that's when it started. Whatever that output is, that's what it started with. So in table A, I can't see what it started with. I could try and work the pattern backwards. That's what you had to do on the last test to get your y-intercepts to make the equation. You could work it backwards by working the pattern backwards, but if you have X being 0 on your table, you have a y-intercept, and table A does not. Table B, Avery, I believe you chose that one is not belonging. What was your reason? Okay, so this one is the only one that has both X and Y starting at 0. What feature of the graph would that be, class? The origin. So table B is the only one that has the origin. Only table with the origin being 0, 0. For table C, let me see if I can remember. Saul, would you say for table C not belonging? So table C doesn't belong because it has a really high Y value, or really high Y values compared to the others. Okay, that could be a reason. Anyone else have another way of saying that? Like, how significant is it when we have Y values that are really high? Like, what does that tell us, maybe? We are on a new unit, a new different type of functions. And I told you before, like this unit takes things very slow. Like I've not even really told you what an exponential function is, how to see if it is one. But what you should know from the past is how to tell if something is linear or not. All right, so how do you know if something has a linear pattern? It goes in a straight line. If I were to graph these, would these be straight lines? All right, would table A make a straight line? Yes, it would. And I know that. How do you guys know that? There's one here. Table lines are not yes. How do you know it's linear? Oh, okay, so you're noticing that we're timesing the X by 8 each time? Okay, and in linear functions, it's always like mx. So in this one, our slope is 8. Good. Anyone have something else about that? How they know it's linear? I knew it was linear, and what I would like for you guys to start seeing is because my x's go up by a particular pattern for the most part. They go up by 1 except for here, where they go up by 4. And at the same time, my y values are increasing by 8 each time. Except for right here when they increase by 32. Okay, so it's still a linear pattern though, because if I had the 5, 6, 7 on here and I continued the pattern in the y's, it would still be increasing by the same amount each time. So start getting used to identifying things as linear. If in the y's we are adding or subtracting the same amount each time. Is table B linear? Does that one go up by a consistent pattern each time? Yeah, and the x's, what are they going up by?
2.
So that is pretty, when the pattern in the x's is consistent, it's easier to see if there's a pattern in the y's. And what's the pattern in the y's? We're adding 16 each time. That's consistent throughout. Because of that, table B is linear. Now, table C, there is a consistent pattern in the x's. They're each increasing by 1 each time. Is there a consistent pattern in the y's? Here's how you can find out, and this is super important. So if you're like zoned out, you really need to clean it. Just because you don't have to necessarily take notes on this part, like this is still super important. Is it adding the same amount each time? All right, I know it's not, because like if I was trying to see if it was linear, I could ask myself, what could I add to 1 to get 4? And that'd be 3. Am I adding 3 each time? Clearly not, right? So it can't be that I'm adding something each time. What's another way that I could go from 1 to 4? Multiplying by 4. See if that's a consistent pattern throughout. What's 4 times 4? What's 16 times 4? And 64 times 4. So it does have a pattern. It is not a linear pattern. So with what you know, you might have said table C is the only one that's non-linear, and maybe the only way you could tell is because it has like it starts off slow and then it starts growing at a really fast rate. That is characteristic of an exponential pattern, which I've not yet taught you, so I wouldn't expect you to say, oh, table C is the only one that's exponential. I would just expect you to say, table C is the only one that's multiplying each time. Or table C is the only one that has it growing at a really fast rate, something like that. Okay, but anyway, table D. Chris, why did you choose table D is not belonging? That's the only one that in the y's, it's increasing by 4. I mean, that is true. None of the others are increasing by 4. I do agree that table D is a little harder to pinpoint some things that are different, but again, it could be simple. I'll give you a simple one. You could have said table D doesn't belong because it's the only one that doesn't have a 64 in the y values. It just doesn't. But it could be really that simple. There's not much else about table D. Would table D follow a linear or exponential pattern? Pay attention. Would table D follow a linear or an exponential pattern? linear because it's adding the same amount each time for the y's. Okay. All right, so good warm up. Didn't necessarily have to write anything down, but it like a lot of really important skills for this unit are shown in just this little warm up, even though not all of them have been formally taught to you yet. You will get to a point where you have to recognize if it's linear or exponential just based off the table. But anyway, we are on lesson 2 of unit 5, comparing different patterns of growth. By the end, you'll know you're successful if you can use words and expressions to describe patterns in tables. I kind of did that already. And when you have descriptions of linear or exponential relationships, you can write expressions and create tables of values to represent them. I'm recording right now, so always stay caught up in the class. Like if you were absent yesterday, then it's your responsible to watch yesterday's video to get the notes from the basket. Like they're always there for you. Your responsibility to get them. Practice will be in Schoology, Unit 5, Lesson 2. And tomorrow is our first quiz. It's just over these first 2 lessons. So if you, for example, were absent yesterday, you would want to take notes on yesterday's lesson so that you can use them for the quiz. Definitely do the practices. If you're understanding the homework without having to cheat or anything, then you'll probably do well on the quiz. Otherwise, ask questions, email the questions if you have to, but that's our plan for the week. Back to the lesson though. All right, so first thing that is printed on your paper is this activity. So a food company currently has 5 convenience stores. It's considering 2 plans for expanding its chain of stores. Plan A is to open 20 new stores each year. You're going to complete the table for the number of stores for the next 10 years as shown. And then you'll answer if there are N stores 1 year, how many stores will it be a year later? And if there are N stores 1 year, how many will it be 3 years later? So notice they partially filled in the first year for you. You won't have anything for this box right here because there won't be a previous year to this, year 0. Year 0 is when it started, the difference from the previous year. And they're applying the pattern of opening 20 new stores each year. So if they started with 5 and they're adding 20, in year 1 they have 25. And you'll continue that pattern for this column. When it comes to difference from previous year, what does difference mean in math? Subtraction. So I mean, order does matter in subtraction, like you have to make sure you're doing the current year minus the previous year. But kind of like how we looked at it over here in the warm up, like this would be a difference between the 2. It's a positive 16, right? Adding 16. So in this one, what's the difference from year 0 to what's the difference from 5 to 25? What's 25 minus 5? So my difference from the previous year for this row would be plus, I'm putting plus 20. Normally you don't have to put the plus when the number is positive, but I'm putting it to show that it's increasing by 20. Because if it was decreasing, you definitely want to put the negative for the difference. So do that for your practice. Fill in the rest of those 2 columns and then do answer these questions. Don't skip them just because now we're applying algebra. Pay attention to the math that you're doing so that you can make expressions for any amount of stores that they want to say. Give you a couple minutes. Everyone will talk today, even with this being a big class. everyone will talk today, so make sure that we are ready. We're not gonna be reporters all those people. All right. So Ashlyn, what number needs to go here where my mouse is? Kyrie, what number needs to go here where my mouse is? Max, what number needs to go here? McKenna, what about here? Madison, what about here? Wayne, what about here? Lana, what about here? Open and Rufio, what about here? All right, classmates, do we disagree with anything? Does this look good? All right, because if their plan is to open 20 new stores each year, like 20 additional stores, you would have 20 each, okay? This is good. All right. Now for the difference from the previous year. Jaden, what's the difference from year 1 to 2? Macy, what about from year 2 to 3? Bella, year 3 to 4. Aiden, year 4 to 5. Jake, year 5 to 6. Evan, year 6 to 7. We're all year 7 to 8. Emberlyn, year 8 to 9. Julia, year 9 to 10. All right. And normally you wouldn't need to put the plus because it's a positive number. We don't usually put positives. If it's not there, a sign, then we assume it's positive. But I want you to get in the habit of showing what the change is. Is it increasing by 20 or is it decreasing by 20? No, it's increasing by 20. Now, for this part, if there are N stores 1 year, how many stores will there be a year later? Oftentimes in this curriculum, you've seen it before, maybe you just don't remember. They make you fill out a table with a bunch of numbers, and then they ask you to make an equation or an expression. You just need to pay attention to the math that you're doing. And whatever expression you make needs to work for every single value. Like you could plug it in and get the next one. So who thinks they have the expression for number 2? No? All right, table 9. Maybe you tell me or come up with something. If there are N stores 1 year, how many stores will there be a year later? Close. If I were putting this as my answer, I'd probably want to go back and see, does that work? So if I had 5 stores, would adding 25 get me 25? So how can I adjust this expression then to make it work? Make it N plus 20. And now when I do try plugging in some of my numbers, it's working no matter what N is. Does that make sense? So this is my expression, N plus 20, or 20 plus N, same thing. Now, if there are N stores 1 year, how many stores will there be 3 years later? Who thinks they have that one? Wade? N plus 60. Do you guys agree with that? Does that make sense? How did you get that way? So he did 20 times 3, that's going up by 20 each year. Remember, we talked a lot last semester how anytime it's like per person, or whatever, that implies multiplication. So it's 20 times, we do know how many years we're talking about, so 20 times 3 is 60. You could write it like that. You could also say it like this, n plus 20 plus 20 plus 20. Because that would be you doing it for a total of 3 years. All of those are acceptable. I mean, really one is more simplified, but all of those are saying the same thing. Questions on that? I feel like this one, though, out of the 3 that I wrote, I feel like this one is the most obvious linear pattern. Because what's the formula for linear equations? Chris, sit up, please. Whenever you see a straight line, you know it has a formula in what format? I know someone out there knows it, they just don't want to say it. What? What? Oh. Linear. Come on, guys. Think back in your head. Think back to middle school. It was something you learn in math year after year. In your future math, they're going to expect you to recall this already. So linear functions have what equation? Yes. Y equals mx plus b. Out of these 3 setups that we all said they're all right, this one to me is the most linear looking because we have our rate of change, it's changing by 20 each time, being multiplied by what would be our x normally is our years, time, usually x. And then we have it being added to whatever we're starting with, which is usually your y-intercept. So there's that, it just reinforces everything. If it's adding each time the same amount or subtracting the same amount, that is a linear pattern. Questions from okay. So that's plan A, opening 20 new stores each year. Plan B would be doubling the number of stores each year. So you're now going to complete this table following that pattern and do it for the next 10 years. You have an additional column though to fill out that says factor for the previous year. What math do we associate factor with? Multiplication. Someone said division earlier, and like I kind of see where the thought process was, because if you don't know the factor, you can divide and figure out what the factor is. But factors are things you multiply. If you don't know that, write that down. Factors are numbers you multiply together. So if I asked you what are the factors of 10, you could say 2 and 5. You could say 1 and 10. Is what you're multiplying together. So when you're filling this out, you won't have 1 for this row because there's no previous year. Here and here. If they're doubling each time and I start with 5, how many will I have in year 1? 10. What's the difference from the previous year? Good. And for the factor from the previous year, if you don't know the factor, you can divide them. But what did I multiply to get to 10? What did I multiply by 5 to get 10? and my factor is 2. All right, that's how you're filling it out. Do it for the rest. If we're doubling each year, and then also say what the difference is from the previous year and the factor is from the couple minutes, and then same thing as before. You're all going to be called on, so make sure we are in. Okay, so Brayden, how many stores were there in year 2? Chris, how many in year 3? What'd you say? Okay. Let's see. Jordan, year 4? What'd you say? Did you say something? What did you say? Okay, so I'm seeing some looks on some of your faces. Do we want to speak up about something? Is this going good so far? Is this doubling each year? Okay, where is it not great right now? Where? Okay, so what's double? So class, what's double of 10? What's double of 20? So yeah, you guys can pick up. That's our spaces. Because of course, if you make a mistake somewhere, you're gonna end up ruining the rest of them because it's based on the previous year. So yeah. Now let's try this again. Chris, what goes for year 4? What's double of 40? 80. Now, Jordan, what about for year 5? 160. Amy, what about year 6? Can you find it really quick? You guys are allowed to use technology. I'd actually probably prefer that so you're not like just doing mental math. 320. Yeah, I still see like on tests, some of you adding by hand and things like that drives me crazy. You should not be adding and subtracting by hand. Anyway, let's see, where am I at? Jalea, what about year 7? Kybri, year 8. Avery, year 9. And Tristan, year 10.
1001 year 20.
Okay, now it looks all better. So if you made a mistake, that's fine. Just remember when it says it's doubling each year, double in math means multiplying by 2. That's the pattern. Difference from previous year. That's the one where you're asking yourself, what am I adding or subtracting? Because sometimes you add a negative number. But what am I adding to this number of stores to get the next number of stores? So Evan, what do I need to put here where my mouse is? Good. Bella, what about here? Jake, what about here? Madison, what about here? Ashley, what about here? Mandalay, what about here? Ella, what about here? And McKenna, what about here? Did I hear you right? Okay. Max, what about here? Okay, great. That is correct, that column. You might have noticed it just happens to be like whatever this number was. But really, you're asking yourself, what did I add or subtract to get to the next one when we're asking about what's the difference from the previous year? Factor is me asking, what did you multiply by to get the next number of stores? So what are we multiplying by 10 to get 20? Let's see. Ella, what did we multiply by 10 to get 20? No. Emberlyn, for 20 to get 40? Maral? Saul? Jalea? Lana? Blaine? Jaden? Macy? In each row, we multiplied our current number of stores by 2, because that's what doubling is, to get our next number of stores. So that's our factor from the previous year. So we multiplied by. Questions on that? All right, what do we notice about the factor from year to year? It'd be really simple observation. What do we notice about it? Is the difference the same throughout? Is the factor the same throughout? So you could say it's the same. It stays 2 the entire time. Or what do you notice about it? It's always 2 for this situation. It is definitely not a linear pattern, right? Because it's not adding the same amount each time. It's multiplying the same amount each time. This one, if you have room to write it anywhere, because it is having the same factor each time, this follows an exponential pattern. Because of this part right here. Now, the more tricky part, but really it's not, because you guys were able to do the math when it's all numbers. Now just apply a variable. So that way, no matter how many stores I'm saying that there are, what expression would give me the number of stores a year later? There are n stores. How many would there be a year later? Anyone think they have that? All right, table 2, I'm gonna make you figure it out. What expression could I write that no matter what n is, I will always get the right answer for the stores a year later? N times 2. Make that look less out of line. N times 2. Right? If I take my current number of stores and I times it by 2, do I get the next number? Isn't that what I did each time? So you could put n times 2, or you could write 2n, same thing. But that's the expression for it. Now, what do you notice about the factor every 3 years? So if I were to cover up some of this, oh, I guess we can't remember. But if I were to cover up, say, like from, and only look at every 3 years. So like if I only look at year 3, 6, 9, what could I multiply by 40 to get 320? All right, pay attention, this is super important. What could I multiply by 40 to get 320? 8. If you don't know how to figure that out, take 320 divided by 40, that'll give you what to multiply by to get the next number, right? If I were to multiply 320 by 8, does it become 2,560? Yeah. It does. So you could say, for what you notice about the factor every 3 years, you could say it's 8. Where do you think the 8 came from? We multiply 2 to get each singular year. If I'm looking for every 3 years, I had to do 2 times 2 times 2. 2 times 2 times 2 is 8. If you didn't know that. Or 2 cubed, 2 to the 3rd power is 8. So then what expression could I write for how many stores there will be 3 years later? There are n stores 1 year. How many stores will there be a year 3 years later? Table 5, can you tell me? N times 8. Or you could write it as 8n, or you could write it as n times 2 times 2 times 2, or n times 2 to the 3rd power, like lots of ways you could write the same thing. But that will give me, without a doubt, okay, I'm looking at year 1 and I want to know 3 years later, if I did 10 times 8, that is 8, right? That's an expression that works no matter what n is. Questions on that? Making sense? Okay. This next activity is going to be more like your cool down. You have 2 situations and you have A, B, C, D, E, F. You're going to say which situation it best belongs with. So situation 1 or 2. We have a good amount of time. Like, I think we can give you 5 minutes to decide. It probably won't take you 5 minutes. It'll probably take less than that. But when and if you finish early, do start your practice. We'll go over this last one in 5 minutes. So read the situations to yourself. And looking at each A, B, C, D, E, F, tell me, does it go with situation 1 or 2? I'll leave this up because I see people writing, that you're doing the back side of your notes. I'll just 1 and 2. Going over the answers to this. So we have 2 situations. Situation 1, a person has 80 followers on social media. The number of followers triples each year. How many followers will she have after 4 years? And situation 2, a tank contains 80 gallons of water, is getting filled at 3 gallons per minute. How many gallons of water would be in this tank at minutes? So we're not actually necessarily answering these, although we probably could. We're just matching each representation to either situation 1 or 2. So you're going to show me with your fingers A that says 80 times 3 times 3 times 3 times 3. Does that best go with situation 1 or 2? Go with your fingers. Table 7, why do you say situation 1 for that? Because he has a quality number here, and this is like a 4 years and it's 43. Okay, good. The 80 repeats in both. The 4 repeats in both. However, the key thing that really differentiates what it should be is the part that says it triples. Tripling in math is multiplying by 3. So yes, this is situation 1, but the key thing that really differentiates it is the tripling part. All right, and they do it 4 times. It's 4 years. All right, now for table B, does that best go with situation 1 or 2? Fingers. Okay, so it looks like the consensus is situation 1. Table 3, what told you that one was situation 1? What was the giveaway? There were multiple of you that said it. In the Y's, right? Yes. Like if you were to apply the tripling pattern, it's tripling in the Y's. And the Y's are mostly what we look at. All right, the X's are just usually a time frame. It'd be nice if all the time the X's were just adding 1 each time, because then it'd be easier to see these patterns. But in the Y's is where we look. Is it tripling each time in the Y's? And it is. All right, now C, that says 80 plus 3 plus 3 plus 3 plus 3. Does that best go with situations 1 or 2? Show me with your fingers. All right, situation 2 is correct. That one looks similar to A, but we already said A goes with situation 1, so we know elimination. But also in situation 2, it said that it's filling at a rate of 3 gallons per minute again. So we're hearing per, like that usually implies like multiplying by 3 for every additional minute. Or I probably should have phrased that differently. It's 3 times however many minutes pass, right? So 3 times 4 is 12. 3 plus 3 plus 3 plus 3 is 12. So yes, that one is situation 2. All right, now D, the one that says 80 plus 4 times 3, which one does that best go with? Fingers. Okay, so out of all of them so far, I'm seeing the most variation with this one. The correct answer for it is situation 2. Because these two expressions are equivalent to each other. If I were to start simplifying, these both basically become 80 plus 12. Because 4 times 3 is 12, right? There's that. Now table E, show me with your fingers, which one does it go with? All right, definitely situation 2. 1, because it is filling at a rate of 3 gallons per minute, so 3 additional gallons, means we're adding 3 each time. But also we already sorted for that one would have to be situation. Lastly, if it's 80 times 81, does that best go as situation 1 or 2? All right, good. Situation 1 is correct, so we do that one. This over here had like the first initial part the same, 80 times something. This 3 times 3 times 3 times 3 can be condensed as 3 to the 4th power, which if you use your calculator is 81. So yes, those are equivalent. If you did continue the math all the way through, they give you the same answer. All right, and that's it. I wouldn't necessarily pack up yet. You still have a lot of time. I'm gonna do a couple more problems. We can finish it. Some of you have like a really low grade in here because you have a missing on your syllabus quiz. You need to get that done. Want to start strong in the semester. And then tomorrow's our first real quiz.